Welcome to this quantum security and defense presentation. Thank you for being a valued member of our community. Matthias Reidans studied philosophy at the JWG-university Frankfurt am Main. In 1999, he successfully completed the education Berater EDV/Telekommunikation at Gesellschaft für informationsverarbeitende Berufe Mainz. After 15 years with IBM and 5 years with Integrated Cloud Solutions GmbH and tecRacer Project Management GmbH, he works as Senior Project Manager in the service division of Rosenberger Optical Solutions and Infrastructure. He specializes in data center consolidation, transformation projects, and is investigating the innovative potential of quantum technology for the data center business.
Tony and Seki, so really impressive insights with quantum technology and the politics around quantum. Steve, would you be able to share my presentation? Steve?
Yep, sorry, I'm on it. Just give me 2 seconds.
Thank you. So the education institution was a Gesellschaft für informationsverarbeitende Berufe with a focus on IT, technology, and especially SAP, software, and telecommunication markets. So I'm not sure if anyone sees the presentation.
I'm just bringing it up. For some reason, it's not opening. Give me, sorry, 2 seconds.
Okay. So nevertheless, working within IBM, the data center division, my job was working for very large companies to consolidate data centers, especially in the infrastructure business, and that's a lot with technology, that's a lot with critical infrastructure, and that's why I was very deep in this infrastructure and cloud topics until 1999, and then in the year, okay, that's very good, yeah, I can see, yeah, I can see it. So the topic today is quantum connectivity, data center compatibility. Question in which way quantum technology is influencing the data center market, the data center certifications as well, and what kind of focus we should have in regard of the data center topology and architecture. So if you go one slide further, please, Steve. We have a time delay here. So for anyone, Rosenberger Hochfrequenztechnik, indeed is producing the cabling for the larger dilution refrigerators, for instance, for Oxford Instruments and for Light and Cryogenics. So we are on the delivery part, on the manufacturing part of quantum computing. And this is what I found 4 or 5 years ago. And then I dropped as I was finding this into the quantum technology as well on the service side. So my current day job more or less is to perform large data center transformation projects, upgrade of data centers, closing down data centers, evaluating new data center sites and occupying the new data center space with the system. So doing migrations as well. And yeah, maybe please go one slide ahead. And now question is about how the quantum technology, especially the quantum computers, are influencing the data center topology, and in which way we should focus on the quantum data center. So I was recognizing quantum data center is not a term where everyone is familiar with. So what is a quantum data center? Maybe we can just go ahead. easy to find what it's not. The classical data center, co-location data center, enterprise data center do not have any features with quantum technology. AI data centers, the most developing market today, is exactly not what the quantum technology is providing. And the quantum technology currently with quantum computers is focusing on integration with HPC data centers. So supercomputers, HPC data centers are being integrated with the quantum compute modules. And that's why in this presentation, I want to just have shedding some light on the quantum data center and not on the other parts. We could follow this up in other presentations. So maybe just go ahead one, Steve, please. So what is a characterization of a quantum data center? So just, yeah, the clarification. Please go ahead. Yeah, exactly. So proposed criteria for a quantum data center is that a quantum data center is using quantum technology as an essential part of the facility. And I open the presentation on my own. And the next, just a second, I need to open the presentation on my own as well. So it's a bit tricky. The Zoom is such a bad performance that unfortunately it's just having in use with Steve's laptop here. So please just a second. I need to hook on the slide. So please, slide 11. So one step back, please. Could you go one step back, please? Steve, can you hear me?
I can. This is slide 10 I'm on now.
We can hear you.
Slide 10.
Mm-hmm.
Okay.
You need slide 11, which is this one. Quantum data center, upcoming standards for QT. No definitions in
upcoming standards, yeah, okay. Yeah, the view is so much delayed. Okay, I talk about slide 11, yeah. So quantum data center upcoming standards for quantum technology. In current prevailing catalogs where data centers are defined in terms of standards, regulations, and the tier levels where data center are providing their capabilities. This is some European regulation as well as the regional regulations. There's currently no definition for quantum technologies components, but this is upcoming in several work groups, national and on European level and international as well. So standards are about to come. There's a new paper from the Deutsche Industrienorm, the Dean Institute, just published 2 weeks ago about quantum QPUs benchmarking, so that you can compare the capabilities of different QPUs. And this will be shaping the market as well. And this is laying some foundation as well for integrating this quantum compute components into the data centers, because if you want to connect then qubits which are placed and working in different quantum computers, you need to have, for instance, quantum frequency converters, which are not yet existing, and the standards are about to be defined. So this is really an ongoing business currently to follow the standards and definitions in these regulations. So if you please go to slide
Slide 12, we're on.
slide 12. Okay, this is 11. Next slide, yeah, please. Next slide. So more and more companies and more institutions decide to implement quantum computers in data center environments. That's why the regulations needs to be adopted for this new situation. And if we want to foresee this kind of regulatory experience and how we will have some guidelines and hints to implement this technology in the data centers, we need to follow the live implementations currently in quantum computer data centers. So please go ahead, Steve.
Slide 13.
13, okay. 13. So in connecting the data centers, then by use of quantum technology, this will be done by use of implementing quantum secure connectivities in metropolitan networks. So there are a lot of pilot installations and POCs ongoing in Germany as well as in entire Europe. And there, the data center connectivity will be implemented into this quantum secure networks. So this will be a large part of creating a quantum secure infrastructure as well for the data center business in Europe and in Germany. So would you please go ahead to slide 15? 15?
Slide 15, we're on.
15. 15, you should see some components which are not standardized.
Yep, we're there.
Okay. Components which are not standardized. So there's a lot. There's a huge workload ongoing to find the specifications and test beds for all of these devices and integrate these devices into the catalogs, criteria catalogs, and then get an agreement on a national and on the international base to have the definitions to implement this in the data center environment. And there are some lighthouse projects. This is on slide 16. So there's a installation in Japan done in November 2023 in an Equinix data center where successfully quantum computers were integrated as well, like in the LRZ, Leitungsrechenzentrum in Munich. Integration of several components with QPUs from IQM and other companies, and there's a large project ongoing to integrate several quantum modules into the supercomputer Jupiter and the Forschungszentrum Jülich. And this project is part of the Rosenberger competence and connectivity to have this as a lighthouse project to see the connectivity, how it works, and how this pilot installation will then spread out to other projects, and so that we can learn about this, get some more experience. So it's really a challenge to integrate these components into the existing data center landscape. And there are, of course, really huge obstacles and steps to go, because if you create, for instance, a quantum secure networks, you won't have the bandwidth and the performance which is needed for the everyday data center business. So there's a huge gap in following up with this innovative technology and put this into the a broader landscape of data center use. Okay, so this is more or less the current glance view into the data center standardization roadmap for quantum technology. There will be some more details coming up in the later year when the recently published papers are being discussed and integrated in the into a larger audience. And when this will be and when the business is able to rate this for their commercial use. Yeah? So this will influence large parts of the certification landscape for data centers. Okay, so do you have any questions regarding this approach to get the certification path for quantum technology components in the data center business?
I assume that you finished, or you have a few more comments.
Yeah, I do not see the slide. Would you be able to show the slide 18, where the IBM-centric approach is visible?
Yes.
Okay, yeah. Sorry, I have so time delay. I do not see what you see. So slide 18 shows the IBM quantum-centric approach for data centers, which is a very interesting approach, because IBM has created a data center in Böblingen with several quantum compute instances, and make this for public use available, so you can book quantum compute calculation time. So 1 second is available for $1.60, so it's around about $5,000 per hour quantum compute time available in the new IBM data center. And IBM is creating this approach, IBM quantum centric approach for data centers, to get more and more verification and stability into the setup of this data centers. So this was the last part I want to show you, this IBM approach for the centric data center, IBM quantum centric data centers. So do you have any questions?
Actually, I would like to follow up on this IBM. Thank you, Matthias, for a nice presentation on those data centers. I wanted to ask you, how do you see would be now evolving? Like, IBM is a big player, they are putting up the data centers, and obviously they are benchmarking a lot of things that they are interested in. But there's going to be other players coming with their own technologies. Do you think they will have to develop their own data centers to do basically the same, to equally compete on that market? Let's say you have NV Center quantum computers based, and they will need to also create all that infrastructure, because at the moment,
it's a good question. Of course, we have a very much competitive edge. Currently, superconducting systems as well as ion trap systems are very promising in getting a good error mitigation and finally error correction in place. So for sure, all of the competitive companies will watch very closely what IBM is recommending and what success will be done. IBM is currently implementing a new chip into a supercomputer data center in Japan, in Fugaku. So this will be watched as well very closely. And there's the big achievement in Germany is, of course, this Forschungszentrum Jülich Jupyter supercomputer, which will be uploaded by 2 modules from a German company Electron and the Finnish Germany company IQM. So this will be watched very closely, what the capabilities and the key parameters are of this implementations.
Thank you. I think we have a question in the chat.
Okay.
Oh, no, sorry. But I have a hand raised by Nigel.
Nigel?
Is there any other questions? Oh. Matthias, do you see a question from Kevin in the chat?
I try to see it. Yeah, just a second.
It's quite long, so.
Quantum decoherent qubits that are encrypted.
I think that might be relevant to the Li-Fi conversation, that question.
Oh, yes, sorry. It's a conversation.
I see.
Sorry, Matthias, if that's confusing.
Yeah, there's of course there's a discussion going on for connecting the QPUs by entanglement over the internet, and this is a interesting and deep technology field where we will see hopefully much progress within the next year. And because this entanglement can be used for having an exponential power upgrade for the qubit instances.
Matthias, I've got a question. When these data centers are going live, what level of demand is being placed on them when they're going live?
There are good and bad experiences with companies that booked already quantum resources with IBM or with other quantum data centers, because on the one hand, it's noisy, of course, and you cannot have the reliability you need for have the calculations you expect to be done. So the results are somehow unsatisfactory. And on the other hand, there's a problem with the intellectual property. So if you have prepared a lot of challenging questions and requests and algorithms you need to execute, then you need to follow the company's rules for the intellectual property, to obey the intellectual property, because if you create some halfway solution and execute this on a qubit system, and you find this information later on where you will not expect to find it, you have a problem. So that's why some of the institutes are aware that the terms and conditions of using the systems are really critical, and they need to have a deep dive investigation into the protection for the intellectual property of the companies, which is implemented in these algorithms prepared.
Anna, you have a...
I just wanted to
so
thank.
There's some, yeah.
No, sorry.
So there's some kind of reluctance, yeah, with the users, with the using companies for this qubit instances.
Great.
Okay.
Thank you. Yeah. So
yes, thank you so much, Matthias. Thank you, Zeki. Thank you, Tony. I think it was a great session, and unless you, Steve, you have some comment, I think.
no, not at all. No, I'm gonna keep quiet. I think we're done for this week. We'll be back at the same time, same place next week.
Mm-hmm.
If there's anyone on the call that would actually like to speak and present anything, please do drop us a message, just on the community, and we will come back to you. Always looking for speakers. So otherwise, I think we should close out this week, Anna. and wish everyone
Yes.
a lovely Tuesday afternoon.
Yes, have a good one and see
So-
you next week.
Thank you. See you. Bye.
Everyone.
Thank you all.
you. Bye.
Thank you.
Thank you.